Okay, this can be very Leven's problem sets. Who is polar protic? Who is polar aprotic?
DMSO is
polar aprotic.
Good.
Also DNF.
DNF, yeah. And also the ketone is aprotic. Yeah. Ketone.
This one?
Yes.
Okay, it's acetone. This one is,
Also, okay.
yeah, okay, it's aprotic. Okay, what else I have?
Polar protic.
So the rest of this, okay, why these are polar, it's correct. Aprotic means no hydrogen flowing around. I will do the spread out structure later, but let's see this one, okay? Your hydrogen is bound with carbon. Your carbon doesn't want to lose this hydrogen. So you will not have flowing hydrogen in your solvent. Are we good? Really, I use specific hydrogen because like this one, okay? COOH, R, COOH. This is carboxylic acid, right? And this hydrogen can be falling off. If this hydrogen falling off, okay? If this hydrogen falling off, oh, your resonance come to bite you. Resonance stabilize this conjugate base. So it's you can have your hydrogen flowing around. Are we good? Okay, the same goes to this one. This is formic acid. This is acetic acid, formic acid, okay? How about water? You are not going to have water, right? Okay, the real case of polar protic is forming hydrogen bond. It's been written on my notes, it's forming hydrogen bond. But I think using this one is easier to explain. So I use this one as example in my lecture. But this is polar protic, and the same goes here, OH. Are we good? It works the same way as long as you have flowing hydrogen. Even it's partially flowing, it have more positive. And the solventnated, the fact of solventnated, I explained, is whenever you have a nucleophile, okay? Whenever you have a nucleophile, and once you throw your nucleophile into your beaker, it becomes like this. Okay, this is exactly what solventnation. Okay. Okay. Your nucleophile throw in it, and all the hydrogen just form a shell around it. It's not going to attack anyone because it's already being surrounded by the positive. But if it's SN1, the more positive around it, the better your carbocation will be because your carbocation is positive and you have a lot of positive. We're all happy. Nobody compete with me. Then the nucleophile is just going to like attack your carbocation. Are we good? Are we good? Yeah, so that's the solventnation. Solventnation is just like once your nucleophile arrive in polar protic solvent, it's just like this. It's not going to do anything. It doesn't like SN2. Unless you have a really good nucleophile, which is the one example we see, the fast one, nitrogen, then it's going to do SN2 because my nucleophile was so good. Are we good? Are we good?
Yeah.
All right. Let me see if I have time to do one more.